Additive manufacturing is a rapidly expanding manufacturing technique that uses different types of printers to make a part by adding material in layers rather than machining material off. When most people think of additive manufacturing, they think of something similar to what was performed for the Mech 325 Rapid Prototyping Lab. A 3D printer extruding melted plastic onto a platform, adding material layer by layer to produce a three-dimensional part. While this method of additive manufacturing is great for prototyping or producing low-cost plastic parts, it does not have that big of a use in industry. A technology that is rapidly expanding in industry is similar, but uses metal instead of plastic. There are a few types of 3D printing processes that use metal as a material. Direct metal laser sintering, or DMLS, selective laser melting, or SLM, laser metal deposition welding, or LMDW, and electron beam melting, EBM. All of these processes can produce parts of complex geometries in a matter of hours or days instead of days or weeks, and can also produce parts that might not have been able to be manufactured before this technology was available.
Direct metal laser sintering, or DMLS, is a process that uses a laser to partially melt or sinter small metal grains together to make a three-dimensional part. This process is similar to plastic 3D printing in the manner that the printer uses an STL CAD file to automatically generate the code to produce the part, so no code has to be written by the user. This machine begins by laying down a bed of metal powder with a thickness as small as 20 microns onto a printing platform. A laser then melts the powder in the two-dimensional shape of the CAD drawing. For this process, the laser does not melt the metal completely, but melts it just enough to form a sturdy bond between powder particles. After the first layer is complete, the printing platform drops downward. The machine lays down a new layer of powder, and then the laser melts the next layer of material. This process is repeated until the part is complete. This process is an excellent method of producing parts with complicated geometry, as this process is relatively fast and can produce parts with a typical tolerance of 0.003 of an inch. Some materials that can be used with this process are stainless steel, cobalt chrome, copper, titanium. Completed, the excess material is removed and recycled. Then the part undergoes inspection for any surface imperfections.
Laser metal deposition is a similar process to DMLS, except that with laser metal deposition, the material is shot straight into the laser instead of being dumped onto a platform. Typically, the laser material nozzle is controlled by a robotic arm that builds the part layer by layer, similar to a conventional 3D printer that uses plastic. This process is very lengthy to produce a whole part, but it is very useful for repairing parts. Parts such as aerospace components that are very costly to make can be repaired with LMD. Materials used with laser metal deposition are very similar to the ones that could be used with DMLS. LMD can also be used to repair surfaces and to customize a part after it has already been manufactured. To quickly summarize laser metal deposition, it is very similar to DMLS, except material is shot straight into the laser instead of dumping it onto the printing platform. Then the laser creates a weld pool to melt material and create a bond. A robotic arm moves the laser and nozzle together. Great for repairing and customizing parts and surfaces, and can also be used for robotic welding purposes. The materials that can be used with laser metal deposition are the same that can be used for DMLS.